Black holes were predicted by Einstein's theory of relativity, which shows what happens when a massive star dies and leaves behind a dense core. Since their discovery, black holes have been studied at great lengths by astronomers and physicists. Our understanding of them has increased with each new research project, and it continues to grow. In the non-scientific world, black holes have become a big interest in sci-fi movies and TV shows, and have become something that are talked about in everyday households. However, black holes can be misconstrued in media. The following scene shows two students discussing this topic. Sarah knows little to nothing about black holes and is asking her friend Chad, who is much more informed about them, to give her an idea of what they are.
Hey,
What's going on?
so I have a question.
Okay.
I was watching this movie last night and it had black holes in it. I didn't really understand it. Aren't they just like holes in space that suck in light?
Actually, black holes are pretty much the opposite of holes in space. See, when a really big amount of matter is packed into a really small area, very weird things start to happen. Try to imagine a star that's 10 times more massive than the sun, squeezed into a sphere about the diameter of New York City. This causes a gravitational field to form that is so strong not even light can escape.
But I thought the more massive stars are, the brighter they are. How can something so massive not be bright?
Well, black holes are very different than stars. In fact, black holes actually form after large stars die in supernova explosions. If the total mass of the star is big enough, which is about 25 times the mass of the sun, it can be proven theoretically that no force can keep the star from collapsing under the influence of gravity. But when the star starts to collapse, a very weird thing occurs. See, as the surface of the star nears an imaginary surface called the event horizon, time on the star actually slows down relative to time kept by observers far away. When the surface reaches the event horizon, time stands still, and the star can collapse no more.
If black holes are formed from stars that are all about the same size, are black holes all generally the same size too?
Surprisingly, it seems that black holes exist on two completely different size scales. On one hand, there are countless black holes made from the remnants of massive stars that have died. These stellar mass black holes are generally 10 to 24 times as massive as the sun. Astronomers usually find these when a star draws near enough for some of the matter surrounding it to be sucked in by the gravity of the black hole, churning out X-rays in the process, which is what we see. However, most stellar black holes are impossible to detect. But judging from the number of stars large enough to produce such black holes, it's estimated that there are as many as 10 million to a billion such black holes in the Milky Way alone. On the other end of the size spectrum, there are giants known as supermassive black holes, which are millions, if not billions, of times more massive than the sun. Astronomers believe that these supermassive black holes lie at the center of virtually all large galaxies, including the Milky Way, and they can be detected by seeing their effects on nearby stars and gas.
So will the Earth ever get sucked into a black hole?
Well, if a black hole were at the center of our solar system in place of the sun, the Earth would actually keep orbiting as usual around the center of the solar system. For the Earth to be affected by the black hole, it would have to actually be in the black hole's gravitational field. And the only way the Earth could get sucked in is if a black hole was moving through the solar system and got close enough to the Earth.
So if a spaceship were to fly into a black hole, what would happen to it?
If a spaceship were to travel into a black hole, it wouldn't even make it to the event horizon before being destroyed by tidal forces from the curvature of space-time stretching it out. However, it would be possible for a spaceship to pass through the event horizon of a supermassive black hole because the tidal forces are much less due to the giant size.
Where does the stuff go that gets sucked into a black hole?
Black holes are basically like wells of gravity. At the bottom of all the mass that has been sucked in becomes a singularity, which is an infinitely tiny and dense point at the center of a black hole. But because they can't be observed, they are not completely understood.
I have to get to class, but thank you so much for teaching me about black holes.
Anytime is no problem.